Today I'm going to use OTISS Pro to conduct a trip analysis for a single land use development. The example considers a proposed elementary school with a capacity of 200 students. The site will be served by a single primary vehicle access point with potential impacts on two adjacent intersections. The example analysis evaluates traffic conditions 10 years after the project reaches full build-out. Remember, this is a showcase example only, intended to demonstrate how OTISS Pro can efficiently handle this type of analysis. This is the ITE TripGen website, and we can find OTISS Pro icon at the bottom left corner. Let's click it. From here, we can add a new project. So our new project name will be Elementary School. The scenario name will be 10 years after build-out, and this time let's focus on the AM peak hour. And we also need to do multimodal adjustment for school developments. But in terms of trip production, I don't think we need it at this time. We can click No, and let's click OK to proceed. The first step is to conduct trip generation. Let's click this row to add a new land use, which will be Institutional Elementary School, and let's click Add. Let's enter the size of the elementary school. That will be 200 students, and for the time period, let's select peak hour of adjacent street traffic, 1 hour between 7 and 9 a.m. And for the method, we use the ITE recommended one, which is average. And here we can find OTISS Pro has already helped us calculate the entry traffic, exit traffic, and the total traffic. Let's say 95% of trips will be completed by personal passenger vehicles, and the remaining 5% will be completed by other modes including transit, bike, and walk. And if we pull this up, we can see there is a trip generation summary that is available for view and export. Then the second step, let's go to network configuration. So for the base options, this time we'll use schematic diagram. We can also set north direction here. And let's start by drawing the site using a polygon to represent the school. We can assign land use to the site, and we can rename the site name. Let's call it Elementary School and click Done. And then we can draw straight. So this is the first street. We can name it First Street. This is the second street. Let's name it Second Street. We draw another road. We can say name it First Avenue. Click Done. As you can see, the two intersections are generated automatically when the two roads intersect with each other. And here we can draw the driveway. When we draw the driveway, we connect elementary school with the existing roadway to form a T intersection. We can call it school. Click Save. And the next step, let's build the nodes. As you can see, we have 3 nodes, and for each node we can input the data. Let's click Edit. From here we can enter an existing traffic, define growth rate over the 10 years, which is our horizon years, and we can also define the number of lanes and whether the left turn or right turn are shared lanes. So let's just put some numbers here for illustration purposes only. And let's define growth rate to 2%. I will just input the exact same number and click Done. As you can see, when the ID for an intersection is completed, it will become green. And now let's do the same for the remaining intersections. Okay, now we complete the ID for all the nodes. We can display volumes. Now we can display existing volumes. And we can also display background traffic in 10 years, which will be increased by an annual rate of 2%. So next step, we can go to driveway distribution. Let's click here. In this step, we will distribute school-generated traffic to the driveway. Because we have only one driveway for the development, we can distribute 100% of trips to it. Click Done. And you can see the status will become a green check mark when the distribution is done. And we can also see the distribution summary here. We can choose to show distributed trips and distribute percentage, and it will show in your diagram. Now let's go to the next step, which is network distribution. In this step, we are going to distribute traffic to the road network. Click on the driveway, which is school access, and click Add New Route. And we can start create our route here. This is the first route. We click OK. We can name it as westbound through. Click Done. And we click Add New Route. We add this route. We can call it westbound right. Click Done. And add a new route again. This time will be westbound left. And let's create another route. So this time will be eastbound through, eastbound left, and eastbound right. Okay, so we can also assign the percentage of trips for each route for both the inbound and outbound. For illustration, let's just assign some random volumes here. So the assigned trips is 100% and unassigned trips is 0. So we can click Done. And we can also see our assignment summary here. We can see the specific volume of each movement for both inbound and outbound. Now let's go to the final step, which is the turning movement volumes. In the final step, we can display traffic volumes for different conditions. We can display the volume for existing traffic, for background traffic, for sign-generated traffic, pass-by traffic, and for build-out traffic after our horizon year. And we can also export our results in Excel or CSV files. Choose the file you want or select all and click Export, and it will be downloaded to your laptop. And if we go back to the folder, for instance, if we are going to make another scenario called PM peak hour, we can copy our existing scenario, and we can edit our copied scenario. We can name it as PM peak hour. Click Save, and we can start to edit this scenario and do analysis using OTISS Pro, such as we can choose the time period to PM peak hour. So thanks for watching the video today. I hope it can be helpful. Have a nice day.